What's going on, guys? Today we're working on my John Deere LT166, 16 horse Briggs & Stratton on it with the 42-inch Freedom mulching deck. Just sharpened the blades on it. And one thing I noticed after greasing the deck and greasing the spindle bearings was that the steering's pretty loose and lopped out, as you can see. It's got a pretty good amount of play. You see the gap right there that it has in it. That's not on just this side. It's also on this side as well. So no bushings in this at all. It's all pretty much worn out. So what I'm gonna do is go ahead and 3D print some, see how they work out. If they wear down, it's not a big deal. I'll just machine some when I have some time, but we're just gonna try to do some 3D printing. So we're gonna take this stuff off and get some measurements. Sorry everyone, I forgot to rotate to landscape instead of portrait, so the rest of this video should be in landscape mode. But anyway, you can see right here, oh, if it'll focus for me. You can see it's pretty worn out. It's pretty much oblonged in here. And if you look at the actual shaft itself, it's, needless to say, it's pretty worn down. A lot of years on this. I think this model was made from 99 through 2001, somewhere around there. So it's got a lot of years on it. But this one's even worse. I don't think the video really does it justice for the amount of wear that it has on it. See pretty good right there. How much wear is on this thing? So we'll get some measurements of the OD of this, the ID of this bore. Just print some bushings for it, and if it feels better, if it, turns a little tighter, we'll go ahead and machine some wear ones out of steel or aluminum. We'll see. But, yep. And here are the measurements we got for the right front and left front. You can see the ODs are 660 and 612. Left front wore a lot more, like 160 thousandths on the left front compared to about 100 thousandths on the right front. So just next video should be designing a couple bushings. All right, guys, so we're going to use my CAD CAM software, Mastercam. That's what I use for designing and stuff. A lot of people use SolidWorks or like Fusion 360 and stuff like that, but this is just what I'm most familiar with, so that's what I'm going to use. So we'll start off by just doing the general sizes of the holes and stuff like that we need. So we'll start with the right front one. The ID was 612 and the OD was, looks like 566 to 500 because it had that wear spot to it. So we'll go up here, make a nice little center point. Make this diameter for the outside. So I'm gonna make this 750, and what this is gonna be a little step. You'll see when it's done. Do this next one. We're gonna make this the we're gonna make this 600. So the ID of it was 612 that we measured. We're gonna make it 600. Just give it a little bit of wiggle room. Just because I know that 3D printing makes it a little bit bigger. Don't know exactly how much, but we're gonna make that 600. And then for the hole, we have a range from 566 to 500. 500 is obviously the small part, but we need it to be at least 566 in order to go over the actual pins, or the actual part that goes down into steering linkage thing. So we'll make that 575. Make that a little bit bigger. So diameter 0.575. Yeah, it doesn't look like much, but that's what it is. So for the first one, I'm going to go to solids, extrude. I want to extrude this top surface here. I will only go down about like 50 thousandths, just enough to give it a little bit of a lip to it so it can sit on. And then I'm going to make this outside surface here go down as well. And that's going to be going down, let's go 350 thou. So it goes down that direction there. And finally, I know this is probably not going to work, but we're going to try it anyway. Yeah, I didn't think it was going to work for cutting this hole. Try one more time before I change it up. Go that direction, try it, cut body. No, okay, no biggie. So we'll just come up the hole here. Select the surface. I'm going to start it right in the center. And the diameter is going to be, the 575. And then I want to go through all. That should be right. Oop. That position went away. There we go. So now you can see that's going to be the bushing. This is going to sit on top right there. A rod's going to go through the hole. And this is going to be the bushing around there to kind of take up that extra space. So I'm going to go ahead and save this guy. Pretty simple. All I have to do is take this, translate it over. Green check mark. So this is my one side. We're going to make this one the other. We can manipulate this one easy. This one's going to be the left front. The ID of this was 660. So I'm going to make this. I'm going to change this up a little bit. All right, so it goes right, left, right, left. So the first and third is what we're doing. I wonder if I can rename this. I think I can. Solid. Oop. There. At least now I know what one's which. So we'll start with this right here, which should be, that's fine. I think the extrude is the piece we want to change. So we need to change the diameter of this because it's saying our inside diameter was 660. So this needs to be bigger. We're going to make that, we'll do 650 on this one, 10 thou. So in order to change that, all we have to do is come to this geometry here, select that geometry. We want to analyze the entity and change that from 660 to 0.650. Enter, you can see it expands out a little bit. Have to regenerate it. You can see it automatically changes the size of that. And then for our hole, which is this guy right here, we're going to keep that at the 575 as well. So that's all we got to do. Now we can put it into our Creality 3D printer, slicer software, which is the next thing you're going to see. So we're going to save this as a STL. We'll put lawnmower spacers. I'm going to save it first as an MCAM, so that way we can always come back and edit it later on. And we're going to save it this time as a STL file, basically is what it is. I'm going to save that. Go ahead and save it, and I'm going to start up my Creality slicer software. while that's popping up, wait a second here. Hopefully this works, and if not, like I said, we can just come back and edit it quick. Not a big deal. Reprint it. What's nice is we have all the geometry right here. We can just change it on the fly. Like this one's pretty. This wall on this is pretty thin. This one's pretty thick. But even if it doesn't fit, I can sand it down a little bit. What I really want to do is get the dimensions correct, so that way I can like machine these spacers out of aluminum or steel. Obviously, these won't last too long because they're plastic, but that'll help a lot in the meantime. Okay, so now all we have to do is import our file. Oh, don't want that. One thing is, since I use everything as a standard size in Mastercam, anytime you import something into like a slicer like this, it automatically scales it to metric, which is a little annoying but not horrible. So what I have to do is, since the models are already selected, go to scale, and we multiply this by 2,540%, and that's the standard conversion to go from metric to standard. So right there we can see, boom, there's our parts. They're on the build plate. One thing I'm going to change is I'm going to flip them upside down, so that way it doesn't try to throw supports on this brim right here. So again, since the model is selected, just go to rotate, and I can rotate this guy around. Boom, there they go. Let's check out our settings real quick. Let's look for speed. Speed's 180 millimeters a second. Okay, that's fine. Support. I don't want no support. Build plate adhesion. I want to do a brim on this. Do auto brim. That's fine. Let's take a look at it and see what it looks like when it's sliced. Okay, it's not too bad. You can see right here as we press play, it going around and 3D printing everything. You can turn the speed up a little bit so it goes a little faster. You can do each individual layer like this as well, or you can do each layer so it'll build it up as it goes. I'll slow it down. Ooh. So kind of cool. So the next thing you guys should be seeing is the time lapse of the 3D printer printing these parts out. All right, so we were able to get these back on. They fit pretty well. Had to tap them in a little tighter than I thought they were going to be, but for the most part, that one's in pretty good. And so is that one. Really hard to see, but if we go ahead and hold it like this and try to jiggle the wheel, we don't have any real play too much in there compared to what it was. I mean, this is plastic, not aluminum or steel, so there's going to be some give to it, but a lot better than it was before. So, yep, mission accomplished. We'll go cut grass and see how it turns out.